This is lesson 9.3. We're taking the square root method in order to solve quadratic equations. In the previous examples we did, all of them were able to be evaluated using square root, and we didn't end up with anything that was not able to be completely square rooted. So in these examples, we actually have things where we're going to come up with numbers that are not able to be simplified using the square root wholly. So what that means is that you're going to have to round to the nearest hundredth. Now, that would be what we were going to call an approximate answer. We are also, when we're solving these, going to be finding an exact answer, okay, using square root method. We're going to look at a couple of examples and try them, and I'll show you the difference between exact and approximate. Remember, in the first part of the lesson, the idea was to isolate this x squared term so that we'd be able to take a square root. Okay, so we'll take a square root. In this case, we're going to get x is equal to plus or minus the square root of 2. That's our exact answer. There's nothing else that I can do with that. 2 is not able to have us take a square root. Now, the problem is the square root of 2 is difficult to graph. So, if I'm going to do an approximation, I should definitely reach our calculator, Desmos or TI calculator. Any kind of scientific calculator with square root will be fine. The approximate answer is based on the exact answer. So all you need to do is you need to take the calculator and you need to do the square root of 2. And you're going to round, so I'm going to write an approximation symbol, right? And this is going to be about 1.41. So in terms of graphing this, you could find the vertex and you could find the y-intercept and those things, and you could plot some points that that fit. But if you're specifically looking for the x-intercepts or the solutions, those are things that are going to be square root of 2. And since those are not going to appear on the number line because they're an irrational decimal, we would use 1.41 as our approximate answer. Okay. Something similar happens in number 20. So at this point, I'm going to skip it. But looking at 21, again, subtract 25 from both sides. Going to get x squared is equal to 24. Okay. Square root that. In this sense, it's going to be x. In this sense, it's going to be plus minus root 24. Now, the problem is that we know root 24 can have a simplified form. So this one is really going to simplify down to x equal to plus or minus 2 square roots of 6. And this will be our exact answer. So positive 2 square roots of 6 comes 0, and negative 2 square roots of 6 comes 0. We're going to have our two solutions. Now, in terms of approximating, I'm going to grab a calculator. I'm going to take the square root of 6. I'm going to double that amount, and then I'm going to apply my plus minus sign. So it's going to be positive, negative 4.90. Okay, and that's our approximated value. And how did I come up with the approximated value again? I simply used that and a calculator in order to do the math, give myself an estimated amount. Okay. Looking at 23 and 24, subtract first. 6x squared equal 15. Divide the 6. So x squared is equal to 15/6, but since we know they're both divisible by 3, we're really talking about 5/2. Now we take the square root, plus or minus the square root of 5/2. Now we learned the other day in lesson 9.1 that we're not allowed to leave a radical in the denominator. So this is really plus or minus the square root of 5 over square root of 2. We would have to rationalize by multiplying the top and bottom by radical 2. So this is going to be plus or minus the square root of 10/2. This would be our exact answer. Okay. Now, again, if we want to approximate, we simply use the calculator, take the square root of 10 using the calculator, divide that amount by 2, and find our approximated answers. So I'll just move over here so I'm running out of room. This is going to be plus or minus 1.58. Okay, to the nearest hundredth. So in terms of graphing this, we could graph that one, it wouldn't be a big deal. Find the vertex, find the y-intercept, plot a few points, but plotting this is a problem. So 1.58 is going to be an acceptable answer. as far as the solution goes. Number 24, okay, move some pieces around in order to get this to be a positive. So I'm going to move the 4x squared to the left, from the left rather to the right. I'm going to subtract the 18 back the other way. 2 is equal to 4x squared. Divide both sides by 4, so I'm talking about 1/2 is equal to x squared. And I'm writing the square root. So x is equal to plus or minus the square root of 1 over 2, which again we know is really square root of 1 over square root of 2, and we're going to rationalize one more time with square root of 2. So our answer is going to be plus or minus the square root of 2 over 2. This is our exact form, and that's the best answer. And then if we want to approximate this one, right, square root of 2, we know is about 1.41 divided by 2, so this is going to be plus or minus 0.71 approximately. 25. A ball is dropped from a window at a height of 81 feet. The function negative 16x squared plus 81 represents the height of the ball after x seconds. How long does it take for the ball to hit the ground? So obviously we want to figure out, so at ground level h is 0. So we're going to try to solve this using square root method. If h is 0, and we want to use square root method to solve, we're obviously going to move 81 to the other side. I propose we move the 16 instead to make it positive. So I'm really talking about 16x squared is equal to 81, because if I move the 81, I'm going to still change signs anyway. So in this case, I'm just saving myself that step. Obviously, divide by 16 on both sides. X squared is equal to 81 over 16. Fortunately, this one is able to be square rooted easily. So this is going to be 9/4, positive or negative. Okay. Now, that means we're either talking about negative 2.25, 0 or 2.25, 0. In context of the problem, since we can't go back in time, that's not a viable solution. So our best answer is going to be 2.25 seconds. Okay. Last one, 26. The volume of a cone with height h and radius r is given by the formula volume equals 1/3 pi r squared h. Solve for r. Then find the radius with 27 pi cubic inches and a height of 4 inches. Back in the first unit of the year, we did something called literal equations. And that's where we isolated pieces and moved them around in order to solve for a particular variable. So this time we're going to multiply both sides by 3 in order to get rid of the 1/3. So we're talking about 3v is equal to pi r squared h. This says it wants us to solve for r, so we're going to divide both sides by pi h. So I'm doing with 3v over pi h is equal to r squared. And obviously I'm going to square root both sides. So the square root of 3v over pi h is equal to r. Now, giving us some information, we have a volume number, we have a height, so we're simply going to substitute those things in. 3 times 27 pi over pi times 4. We're going to clean this up a little bit, so we know that the pi can cancel out at the top and bottom, and we know that 3 by 27 happens to be 81. Okay, and now we're ready to take the square root. We're doing plus or minus 9 over 2. Okay? Now, clearly can't be a radius of a negative number, so r equal negative 9 over 2, not a viable solution, but r equal 9 over 2 or 4.5 inches. That's our best answer.